So good morning all. In this section we will see the propagation of EM waves in perfect dielectric. Some formulas related to the propagation of EM waves in perfect dielectric. Earlier we saw how the EM wave propagate through a lossy dielectric medium, and we derived expressions for alpha and beta. So here what we are doing is we are substituting certain condition into that alpha and beta, that's all. Okay. So if you are asked to derive expression on any medium, first what you have to do is you have to write 2 or 3 sentences connecting that medium. After that you can go directly into derivation. Okay. So starting with propagation of EM wave in perfect dielectric or a lossless dielectric. The condition is sigma is equal to 0, epsilon is equal to epsilon 0 epsilon r, and mu is equal to mu 0 mu r. And we have the formula for alpha and beta as given in equation 2 and equation 3, which we derived earlier. And into that formula 2 and 3 I am going to substitute sigma is equal to 0. So if I substitute sigma equal to 0 in equation 2, I will get alpha is equal to 0, and if I substitute sigma, that is the conductivity, is equal to 0 in 3, then I will get beta is equal to omega into square root of mu epsilon. That's all. Next we will see the velocity of an EM wave in a medium, that is in this particular medium. So which is given by V is equal to omega by beta. And you know omega by what is beta? Beta is equal to omega into mu epsilon. From that you will get V is equal to 1 by square root of mu epsilon. And here you can see the relation connecting the velocity of electromagnetic wave in the medium, and C is the velocity in air, and the relation connecting V and C is V is equal to C by square root of mu r epsilon r. Okay, mu r epsilon r, because in this case mu 0 and epsilon 0. V is equal to C by square root of mu r epsilon r. Okay. Now next we will find the expression for lambda. Lambda is equal to 2 pi by beta is equal to 2 pi by what is beta? Omega into square root of mu epsilon. Okay. Just mere substitution is there. Then we know what is intrinsic impedance. Eta is equal to square root of what? J by j omega m by sigma plus j omega epsilon, and here I am substituting the sigma is equal to 0, so that I can write what? J omega mu by j omega epsilon. That finally I will get it as eta is equal to square root of mu by epsilon. And that's all in this section. So here you have to keep these formulas in mind, that is alpha is equal to 0, attenuation is equal to 0, beta, the propagation constant, is omega into square root of mu epsilon, and the wave velocity is given by the formula 1 by square root of mu epsilon, and this is a relation connecting V and C. V is equal to C by square root of mu r into epsilon r, where C is equal to 1 by square root of mu 0 epsilon 0. Okay. Then lambda is equal to 2 pi by omega square root mu epsilon, and eta is equal to square root of mu epsilon. Next we will see the propagation of EM wave in free space. For free space, epsilon r is equal to 1. Similarly, mu r is also equal to 1. Okay. So I can write epsilon is equal to epsilon 0 and mu is equal to mu 0. And in free space, sigma is equal to 0. As we did in the previous case, I will be substituting sigma is equal to 0 in my alpha and beta. So I will get alpha is equal to 0 and beta is equal to omega square root of mu 0 epsilon 0. In the earlier case it was mu epsilon, here it is mu 0 epsilon 0, which is equal to omega by c, where c is equal to 1 by square root of mu 0 epsilon 0, whose value is 3 into 10 raised to 8 meter per second. Similarly, we have eta is equal to square root of j omega mu by sigma plus j omega epsilon. If you substitute sigma equal to 0, you will get mu by epsilon. Mu is equal to mu 0 mu r by epsilon 0 epsilon r. Here mu r and epsilon r is equal to 1. Okay, mu r and epsilon r is equal to 1. So finally I will get square root of mu 0 by epsilon 0. Mu 0, you know the value is 4 into 10 raised to minus 7, and epsilon 0 is 8.854 into 10 raised to minus 12. So finally when you simplify, you will get the intrinsic impedance for a free space as eta is equal to 120 pi, it is equal to 377 ohm. Okay. So these are the expressions for alpha, beta and eta for a free space. Next we will see the propagation of EM wave in a good dielectric. In a good dielectric, these are the conditions: sigma is equal to infinity, epsilon is equal to epsilon 0, mu is equal to mu 0 mu r, and sigma is much greater than 1. Or in other words, you can say sigma by omega epsilon is much greater than 1. Okay. Because sigma is much greater than omega epsilon. So here also we will start with alpha and beta. So you know what is this is alpha and this is beta, and we have sigma is equal to infinity, epsilon equal to epsilon 0, mu equal to mu 0 mu r. So when we substitute this condition in alpha, we will get alpha. When you substitute sigma equal to infinity in alpha, you will get alpha is equal to omega into square root of mu epsilon by 2 into sigma by omega epsilon. Because here sigma is infinity, so sigma by infinity will be a larger value. So I can write 1 plus sigma infinity is nearly equal to sigma by omega epsilon. Okay. This term, that is this sigma plus omega epsilon square, omega epsilon the whole square will be a large term. So 1 plus sigma plus omega epsilon will be nearly equal to sigma by omega epsilon. So this entire term which is inside the bracket can be written as simply sigma by omega epsilon, because 1 plus sigma plus omega epsilon is nearly equal to what? Omega epsilon the whole square, and that whole square is inside the square root. So what happens? It will be equal to sigma by omega epsilon. So I am taking this omega square inside. So finally omega and omega square cancel, epsilon cancel. Finally I can write alpha is equal to square root of omega mu sigma by 2, and instead of omega I am substituting 2 pi f mu sigma, and so I can write alpha is equal to square root of pi f mu sigma. And similarly, if we are substituting the same condition sigma equal to infinity in beta, the same condition we have to follow, because here sigma by omega epsilon will be a larger value. So I can write 1 plus sigma by omega epsilon the whole square. It can be nearly equal to sigma by omega epsilon the whole square, which is inside the square root. So I will get finally what sigma by omega epsilon plus this 1. That is also nearly equal to what? Sigma by omega epsilon, because sigma is infinity. So after applying that condition, we will get beta is equal to omega square root of mu epsilon by 2 into sigma omega epsilon, which is equal to beta equals square root of mu omega epsilon by 2. That's all. So this and this is very important. If you study this, you can it's enough to substitute the condition for different media to find the corresponding equations. Okay. Then you can find velocity v is equal to omega by beta. Beta you have already derived here. So omega by square root of omega mu sigma by 2. So finally you will get v is equal to square root of 2 omega mu epsilon. Then similarly you have intrinsic impedance eta is equal to j omega square root of j omega by sigma plus j omega epsilon. So since sigma is infinity, this denominator term sigma plus j omega epsilon can be written as nearly equal to sigma. So I can write square root of j omega mu by sigma. So the amplitude is square root of omega mu by epsilon. The modulus of eta. When I am taking the modulus of eta, I can remove this j term. So modulus of eta is equal to square root of mu omega by epsilon, or in the polar form you can write eta is equal to square root of omega mu by sigma angle 45. So this shows that the electric field in this medium will lead the magnetic field by an angle of 45 degree. Okay. And that's all. We have derived the expressions for alpha, beta, v and eta for different medium, and these derivations are very important. Please write down and study. Thank you.